Today I'm going to talk about section 5.4. We're investigating and applying the cosine law in acute triangles. So what I've done is I've drawn in an acute triangle, A, B, C, and I've labeled the corresponding sides opposite to the angles. So here's angle A, and opposite to the angle A is little a, is the length of this side. Here's angle B. Opposite to angle B is little b, which is the length of this side, AC. And here's angle C, and opposite to angle C is the side little c, which is A to B. This time I won't go into the derivation of the cosine law. It's very similar to the derivation I showed you the other evening of the sine law. Essentially what you're doing is you're creating two right triangles and using cos to figure out the different lengths along the side, and that's how they come up with the following formulas that you see down below. So the cosine law states that a squared equals b squared plus c squared minus 2 times bc times the cos of a. B squared is equal to a squared plus c squared minus 2 times ac times the cos of b. And finally, c squared is equal to a squared plus b squared minus 2 times ab times the cos of c. Now, how can you recognize when you can use cosine law? Well, the cosine law can only be used when you have the following two conditions that are met. So the first condition is you have two sides and the contained angle between the two sides, as you see here. So here's the angle and two sides. So the angle is contained within the two sides. The other option in which you can use cosine law is you have the measurements of all three sides and you don't have any angles. So now let's look at a couple of examples. I've drawn in this triangle ABC. Uh, we're only given the angle of C is 43 degrees, and we're given the length of little a is 7 and the length of little b is 5, and we're asked to find what the length of C is. C is equal to what? So again, we have side, angle, side, so two sides and the contained angle between the two sides. So we can use cosine law. So this will be c squared is equal to a squared plus b squared minus 2ab times the cos of c. C squared is equal to 7 squared plus 5 squared minus 2 times 7 times 5 times the cos of 43 degrees. Let's clean this up a bit. 7 squared is equal to 49 plus 25 minus 70 cos 43 degrees. Come up here. C squared is equal to 74 minus 70 cos 43 degrees. I want to take the square root of both sides. C, oops. So C is now equal to, and the question in the textbook asked to round off to the nearest centimeter. So this would be roughly 5 centimeters. There appears to be some issues with calculators. So if you have one of those calculators where you can enter things as you go, some of the more modern calculators that do that, one, you would hit second or shift. Then you would hit either your x squared key for the so that you can get the square root. So shift x squared, which gives you the square root. Then you would enter bracket 74 minus bracket 70 bracket cos 43 close bracket, and then hit enter or equals. So in the first example that we just finished, we're trying to find a side length, so everything is straightforward as you see in one of the forms of the sine law. However, in this example, example number 2, again, this meets the condition. We have all three side lengths, so we can use cosine law, okay? And we're asked to find angle R, okay? You're going to have to do a bit of rearranging. If these letters mess you up, you can always just erase them and change them to A, B, C if that makes you more comfortable. I'll just use the letters P, Q, R. It's just as easy. Okay, so that means this form of the equation is going to be little r squared is equal to little p squared plus little q squared minus 2 times p times q times the cos of angle r. So let's fill in some of this information. Here is little r, this is little r, here is little p, and here is little q. So r squared is 3.2 squared. Um, Let me do this a different way. Let me rearrange all the letters first, and then let's try and solve this. Okay, I'm gonna do something very, very quick. Um, without showing all of the algebra, but you should by now know that if you move something from this side of the equation to the other side of the equation, it changes sign. So notice how there's a negative sign in front of this 2pq cos r, and there's a positive sign in front of, or it's understood that this r squared is positive. So I'm going to rearrange this so that it's 2pq times the cos of r, because we want to find angle r eventually, is equal to p squared plus q squared minus r squared. Now, in order to get cos r all by itself, I'm going to divide both sides by 2pq. So I'm going to divide this whole expression on the right side by 2pq. This here cancels to 1. So now I have an expression where it's cos r is equal to p squared plus q squared minus r squared, all divided by 2 times p times q. Now, because we're looking for the angle, we have to use the inverse cos function. So angle r is equal to cos inverse of this whole expression, p squared plus q squared minus r squared divided by 2pq. Well, I have all this information now, so angle r is equal to cos inverse of p squared is 5.9 squared plus q squared is 6.2 squared minus 3.2 squared, all divided by 2 times 5.9 times 6.2. When you make this calculation, we get a measurement of approximately 31 degrees. So this concludes the lesson for this video. Remember, please make your own notes, summarize some of the key points, and come to class tomorrow with some questions for clarification. All right, take care.